We're going to look at one example on how to take an empirical formula and turn it into the actual formula, also known as the molecular formula. Again, make sure you understand the vocabulary behind these before looking at these examples, or this is going to be a kind of a big stretch for you to really be able to understand them. So again, make sure you have either really taken your time reading through this section of the chapter, or watch the Tyler DeWitt video where he does a breakdown of what an empirical formula is versus a molecular formula. So we spent the last mini tutorial doing some examples with a shortcut method that I showed you on how to determine an empirical formula whenever you are given a sample either in grams of individual atoms or of percentages of individual atoms, and taking that into determining what the empirical formula is. The molecular formula, which is the actual formula, in that case, we typically need a multiplier in order to go from empirical to molecular, as you should have read or watched in the Tyler DeWitt video. So this one I'm going to kind of do just like a culminating video where we're going to determine empirical, and then the second half is going to ask you to determine molecular. I think a lot of your homework assignments will actually just straight up give you the empirical formula and then just pick up there and have you do the molecular, but I thought it was good just to kind of get a big picture of what this looks like all together. So we're told a compound contains carbon and hydrogen. And it has a molar mass of 78.1 grams per mole. So this is kind of new information that we weren't given before. And that information is important whenever you are asked in order to find the molecular formula. So even though we're not asked to find the empirical formula, in order to find the molecular formula, your first step is you have to know the empirical formula. And you'll either know it by A, being given the empirical formula in the problem, or 2, you have to figure out what the empirical formula is using the steps that we went over in the prior video. So we're going to go ahead and find out what it is. Since we're not told it, we're told it is composed of carbon and hydrogen. We know from before our first step is to take percent and put it into grams. We're told we have 92.3% carbon. The rest is hydrogen. So we know that percentages have to add up to 100. So all we would have to do to find out how much hydrogen there is to take my 100%, subtract out the 92.3% that's carbon, and then that'll tell me that I have 7.7% of hydrogen that's made up of the rest of the compound. So carbon, remember first step, percent to grams. So all that means is you can just drop the percentage and put it into grams. Easy first step. Okay, percent to grams. Next step is grams to moles. So we're gonna go ahead and convert each of these into moles. Okay, remember, whenever you do that, try to keep out as many possible places past the decimal point as you can. I always recommend doing 4 to 5 sig figs at a minimum. Again, if you find yourself rounding these or cutting them off too soon, sometimes you can find yourself in a tough place at the end of these problems because they're not going to work out right. Right, after we do percent to grams, grams to moles, then we compare all of our moles. There's just 2 in this case. Pick the smallest number, and they're super close, but this one's going to be a little bit smaller. And then we divide every single compound or number by that smallest number. Right, so then this obviously is going to be 1. Whenever you do this one, it's like 0.99396. That's an instance where you can just bump that up to 1. You don't have to keep that as a decimal. Like I said before, the only ones you would want to keep as a decimal would be like if it was 0.5. If it was smack in the middle, you couldn't round that up. A 0.33 is too high to round, and like a 0.25 is going to be too tough to round. But anything outside of that, you can do a little bit of wiggling, bumping up or down to get it to that whole number. Last step is multiply till whole. You only do this if you don't have a whole number. We do have a whole number, so we can disregard that last step. So this compound in its empirical formula has 1 carbon and 1 hydrogen. So CH is my empirical formula. Now we know from our reading and or from the Tyler DeWitt video that in order to go from an empirical formula to a molecular formula, you need a multiplier. I think he divided, he went backwards from molecular to empirical, but you need some type of a multiplier between those. So our goal is to find out what that multiplier is. It's a pretty simple formula. To find what your multiplier is, you're going to take the molar mass, molar mass is kind of like one long word, but that should say molar, space mass. This is always going to be given to you in the problem. And you're going to divide that molar mass that's given to you in the problem by the mass of the empirical formula that you were either given in the problem or, like in our case, that we calculated. Okay, so it's a mass to mass comparison. So if we go ahead and do this, the molar mass, which is given in the problem, if I go back up, I'm told the molar mass is 78.1 grams per mole. So that's my numerator. And the denominator is the mass of my empirical formula. CH is my empirical formula, so I would just add up 1 carbon, which is 12.01, and then 1 hydrogen, which has a mass of 1.008. If you add those two together, then you'll get the mass of the empirical formula, which is 13.018, which I'll just go ahead and drop down here. Okay, again, this one you have to calculate based on what your empirical formula is. You're just adding up the masses of the atoms that are in your empirical formula. So whenever I divide those two, I get like 5.999. Again, that's close enough that we can round to 6. So 6 is our multiplier. So what we're gonna do is take CH, these are basically ones, and we're gonna multiply it by our multiplier of 6. And whenever we do that, we'll get C6H6. And that is our molecular formula.